Okay, what did you guys come up with?
All the elements in the metal.
Okay.
It's called D block.
Called the D block. What does that mean?
That's like it's any element in the D block.
Yeah, remember we talked about the shells yesterday, the SPFD? So all your transitional elements have electrons in the D shell. That's what they call the D block. What else do you guys come up with? That was it?
Both the ductile and ductile.
Ductile, okay. What does that mean to be ductile? Or ductile? And malleable? Is that what the other one? Okay. Ductile and malleable, guys, that basically means we can bend them, we can flatten them out. In fact, I want to go back to the PR table here for a minute. You can see right here, SN. SN is 10. It's part of the transitional elements. And what I'm going to actually pass around is a piece of the 10. Something that's unique about 10, as you're bending it, just listen closely as you bend it.
Yeah.
It's kind of cool. All right, so when we think about ductile and malleable, you actually can flatten these out, right? You can hammer it down and get the flat sheets. You can bend them and twist them. And that's basically what it means to be ductile and malleable. Okay, what about metalloids? Let's go over the metalloids.
They are semiconductor.
Semiconductive. What do we mean by that? What does it mean to be conductive?
Make electricity.
Yeah, so that they can carry a current, right? Most of our metals, because of the electron configuration, the fact that they're very reactive, they actually conduct electricity very well. In fact, which metal conducts electricity the best?
Copper.
No. You guys know?
Lots.
It's gold. But I think for obvious reasons, we don't use gold for our wiring. Right? It's very, very rare, but actually conducts electricity the best. That's why a lot of times when you're going in for x-rays and stuff, they want you to remove all your jewelry. Because those x-rays are going to react with that gold extremely well, and you get electrical currents flying through there. And what you don't want is the electrical current being centered right there under your hand. So they want you to remove all your jewelry. So yeah, definitely semiconductive. Because they're not as conductive as most metals. That's where we're starting again to make that transition into the non-metal. So you get a little bit. It's kind of cool because you get the properties of both, right? Did you guys come up with that?
What?
You get actually the properties of both non-metals and
Yeah,
metals.
that was my next one.
Okay, so your properties. Both non-metal and metal. All right, Ashley, what else do you have?
They're usually brittle,
Okay, so we're brittle.
somewhat shiny solids that behave as electrical insulators at room temperature.
Okay, now hold on. I want to make sure we're talking about that. So at room temperature, they act as insulators?
Yeah.
What is an insulator?
I lost it. keeps heat in?
Yeah, you want to think, it basically prevents the transfer of energy. Okay? So whether it's electrical energy or heat energy, an insulator prevents that from being able to be passed along. So a lot of your metal alloys are actually used in ceramics. Okay? And ceramics, guys, are very brittle. Okay? Think about if you've ever used plaster before, it breaks very easily. In fact, glass, right here, glass is considered a ceramic. It actually prevents the transfer of energy. And they're very brittle. So think about your glass again, it's very brittle. You can break glass very easy. And so in fact, glass is mostly made out of silica, which is made from the element silicon, or silicon. So those are some very things there. So very, very important again. You have brittle and insulators. Again, that's going to be used for ceramics or used in ceramics. So for those guys who are thinking art, in fact, this is really kind of a cool deal. If you guys are interested in art, and you really like the idea of becoming somebody who wants to get involved in ceramics, or you're making bowls and glazes, chemistry plays a very, very important role. In fact, last year when we were starting to clear out a lot of our really nasty, heavy metal stuff, Mr. Ober came upstairs, or not upstairs, well, at the time we were all on the same floor. He came over to the science department and started going through our chemicals that we were about ready just to recycle and get rid of. And he said, I could really use that to make this color of a glaze. So again, chemistry plays a very important role in the glaze formations for ceramics. So you get different colors from different elements. So again, it's really, chemistry is more than just being a chemist. You really have to have a foundational understanding for chemistry to do almost anything. And it really helps you become an expert in your field. Okay, next one on our list are halogens. Who got the halogens? Okay, Alex, what you come up with?
R5 non-malleable.
Malleable?